All right. So yeah, binary search is a very common interview question. And it does require a recursion for it to work. So let's actually just take, let's go ahead and first thing I need to do, I'm in Platoon binary search. I'm going to fork this over to my personal GitHub. Tom Preet, there it goes. It's copying it over. Tom Preet binary search, fork from Platoon binary search. I'm going to clone it down. So copy that over there. And now I'm in my desktop CP challenge, my Papa challenges. I'm going to git clone the algo binary search from the Tom Preet GitHub. And I have it come up right here. Nope. So I'm going to clear, I'm going to CD and algo binary search, list everything out. And I'm going to open this up into a new VS Code window. And let's just go ahead and do this in Python, just because we've been working in Python. So if I open that up, I've got a spec file and the binary search function. For this, I'm just gonna, for the sake of time, I'm just gonna write the algorithm. I'm not gonna do any unit tests, but let's go ahead and kind of review what the binary search algorithm is. So binary search is an extraordinary common interview algorithm and application question. The goal here is to find the index of a value that you pass in compared to a sorted array. So sorted array of strings or integers. You can read more here. Is this Wikipedia? Talk about the binary search. So let's take a look. So this grabs a random sample between 1 and like 1,000 of unique values, and then we actually sort those values, and we pass those values into a binary search function. So binary search has what is this? Needs to return the value, so like what we're actually looking for, and a list of sorted integers or strings. All right, so here's the premise of the algorithm. So say you're searching for a number to find and a sorted array of integers. You need to find, so essentially this is kind of like the pseudocode, kind of. You need to find the middle value. And if number defined is equal to the middle value, then your target is found. If the number defined is less than the middle value, you essentially slice your array in half, and then you pass that new subset into back into the binary search, and you just keep repeating that. Yeah. And okay. So it's a difficult algorithm, spend a lot of time pseudocoding. So what I'm going to do up here, I'm just going to copy this up here, because this is kind of like the pseudocode, but let's actually write some pseudocode. So, all right. So what we're going to need to do is create a method that takes in an integer or a target number. Sorted array. And so this is where let's see. So if we actually need to keep track of the index, so we need to keep track of an index as well. So like an index tracker, a tracker index, because as the issue that Jonathan ran into, it's like, all right, well, how do you find the index if you're passing in a new array every single time? So you have to keep track of where you are in the array each time you pass, like each time you call it recursively. So it's going to take in a tracker index as well. I'm going to set this initial value to 0 as well, because the initial value is 0 because that's the first tracker index, or that's the very first time you pass in essentially call the array. We're going to set the initial value to 0, and we'll kind of show you what that looks like. All right. So here, find them. I'm just kind of going off of this because we can kind of leverage this to as semi pseudocode. So we can we need to find the middle index. And if we find the middle index, and so if the length of the array is 6, the middle index would be or what it would be 3.5, or I guess if it was odd. So if the array is 1, 2, 3, and we wanted to find the middle index here, we take 3 divided by 2, or I'm sorry, yeah, 3 divided by 2 to get in half, but that's 1.5. So we probably have to round down if necessary. So if the array is, depending on if the array is even or not odd, our middle index might be 0.5, and we'll have to round down. If the array is equal to, so what else do we need? So find the middle value. So here we found the middle index, but now we need to find the middle number. So actually find the middle number of the sorted array. So, so need to find the middle index. And store in middle index variable. And so we can find the middle number of the sorted array by, so the sorted array, so sorted array, and then the middle index. And we can and store in middle number variable. So now we have the middle index and the middle variable, or I'm sorry, the middle index in a variable and the middle number stored in a variable. So now we actually have the number that we're gonna check against. And so we can say hey, if the number is equal, so if middle number is equal to the target number, then return, what is it, the tracker index? Tracker index. We might mess with this later. So return the tracker index. I'm sorry. Yeah, plus the middle index. And we'll show you kind of what that looks like and why that is. If the length of the array, this is just what if the array is 1? So repeat, find number defined, or return 1 if it doesn't exist. So the length of the array that we're passing in is less than or equal to 1. So therefore it already passed this value. If that's not here, and then if the length of the array is less than or equal to 1, then we return -1. So that means it has yet unable to find value in sorted array. That's what this is going to be returning. Else, if the target number is greater than the middle number. So if the target number is greater than the middle number, what do we need to do? So if the target number, I'm just trying to think. So our target number is this, and the middle number is down here, or I would say on this side of the array. Then we need to, split the array. Like essentially just split get the right portion of the array. Split right portion of the array and return the right array, or I guess return. This is where the actual recursive part is. Return the method with the right portion of the array passed in. And I guess that would look like, binary search, target number, and then like the right array, followed by the tracker index. Susan, did you have a question?
Yes, sorry, really dumb question. I'm assuming you mean the like right hand portion and not the correct portion, or did you mean correct portion of the array?
It should return the right, the correct. When you say correct portion, what do you mean? Should be like this, the right section of the array.
Like, yeah, the one you're looking for, as
Yep.
opposed to the direction, right?
So this should actually be, oh, yes. So yeah. Yeah, so if it's less than, hold on, if the target number is greater than the middle number. So if the target number is greater than, oh, okay. Do I have this backwards then?
No, I wasn't questioning you. I just didn't know if you meant like right direction or correct.
Oh, no, yeah, this is the right direction relative to.
Oh, okay, thank you. Thank you for clarifying.
So if I'm like the second guessing myself on. If the target number is greater than the middle number, therefore we want to grab would that be the left side or right side? It'd be.
I agree, it's the right side.
Okay.
The latter portion, yes, the right side,
Right.
yes.
Oh,
So
man.
bigger index numbers.
Yep. Yeah, there we go. Bigger index numbers. It's one of those mornings for me. Bigger, just so I know, index numbers. And then likewise, if the target number is less than the middle number, we'll split the left array, or smaller, I should say. Smaller array. And we'll see what kind of that looks like as well. Because let's see, split the right portion. I think that's good. So what are, just random question, what are two things that every recursive function needs? What two cases?
Base case and a recursive case.
Yep. So this would be the base, I guess. I'm going to bring this down here. So this would be the base case. And you can have multiple recursive cases. And this would be a recursive case. And this one as well. So we have two recursive cases.
Do we also have another base case where it's not there?
Yeah, so I guess this would also be the base case as well. So it either exists or doesn't exist. So two base cases and two recursive cases. All right. So if we go ahead and actually try to get this going, let's pass in target number because we're going to need the target number, array to search through. This is our actual array. And I think I said that we have a tracker index with an initial value of 0. Because what if the array that we're searching through, what if the value is at like index 0? That's a possible scenario. So in that case, we would never have to increase our tracker index when we pass it in. Oh, all right. So the first thing we're going to do, I'm going to up here, we have a middle index equals, we need to take the array to search through, divided by 2, and then round down. How do I round down? Is there like a math floor? There's math floor.
You use 2 slashes.
Or you can just use the 2 division slashes. And that actually rounds down. It's kind of nice. All right, so now we have the middle index. Now we have the middle number, which would be the array to search through and pass in the middle index. Now we can do our first base case. If the middle number is equal to the target number, so if middle number equals target number, we can return the middle index plus the tracker index. So let's kind of take a look. So if I have, this is gonna be hard. 3, should copy this over. This 5, 7. So if we split that in half, what would that look like? So what is this? A length of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it'd be 5 and 5. 5 and 5. Like that. So if we were actually looking through for 7. And the next one would be, we'd pass that in. So we'd split that in half. So that would look something like that. So we pass that in. And then, oop. Seven. Something like that, but then we'd have to keep track of the index. So that would be 0, 1, 2, 3, 4, 5. So would the tracker index be do we even update the tracker index in here? So tracker index plus middle index. I'm just looking at see if my pseudocode is tracker index plus middle index. I think that's what that part is for. So if it's greater than that, we have to update the tracker index value. So that's like just like a visual representation of kind of what we're doing. All right. And now the next part is the length of the array is less than or equal to 1, return -1. So again, this is our base case. This is another base case. If the length of the array to search through is less than or equal to 1. Whoop. We just return -1. Now we can jump into our recursive case. And now we can say like, all right, if the target number is greater than the middle number, how do we grab like the correct array or right array or greater array equals array to search? How do we slice through this to just grab the left side or would that be the left side? I don't know why I'm having such a hard time with that part. So like the greater portion of the array.
That'd be the right side. You'd update your left index to be your now middle index, and now you're find a new middle.
Mm-hmm.
It would slice your new left versus your old right.
Yep.
And that'd be your new middle.
So how do I actually grab the greater portion or the right side of that array? So this array to search through, if the target number.
Yeah, you don't have to grab the whole array. You just can use it with the index math and just keep updating, chopping your indexes down, and then keep the same array and just reference that portion of the indexes.
I could do that way.
Keeps you from having to rewrite the array as well. It'll be more agile.
So are you saying?
You could also slice.
Yeah.
So
I'm gonna slice the array. That's the strategy I'm gonna go through. So how do I slice the array from just to grab the right side of the index or right side of?
So it could be your start number would be the middle number.
Or middle index?
Yeah, that's right. Middle index, colon, and then you could use the length of the array as the ending.
Like that?
Can't you just leave that last part off and just?
Yeah, doesn't it just automatically go to the end of the index?
Yep. So if I just do like the middle index, which is my starting part, and if I just do colon, it just goes all the way to the end of that. All right. And now I need to updated tracker index would equal the current value of the tracker index plus the middle index. And lastly, I can just return binary search with my target number, which is what I'm looking through, the greater array or greater new array, plus the updated tracker index, like so. Because I'm grabbing the greater array, so I need to update that tracker index. So it's no longer starting at 0. It might start at 5. And I can do the same thing down here. When the target number is less than the middle number, but instead of getting the smaller part of it, I can just grabbing the larger part, I can grab the smaller part. So like smaller array. But I don't need to update the tracker index because I'm working in the smaller section of the array. So the tracker index should still stay the same. So I can just say tracker index like so. And that should be it. So let's actually just take new array. Let's just take like a 1, 2, 3, 4, 5, 6, 7, 8, 9. And actually, let's just bring these in here. Whoop, actually,
Doesn't the, when you reassign to another array, isn't that gonna mess up your index values?
wait, say that one more time.
When you reassign to a new array, so like your greater array or smaller array, the indices will reassign. Oh, let's, I guess, run it and then we'll.
Yeah, the index is reassigned, but that's why we keep track of an index of where we are in relation to the original array.
Oh, I see. Okay.
Oh yeah, let's actually, we've got a very large array and a small array and large array. Whoop. Let's do small array, and large array. Why is that?
I'm sorry, just a quick side note. How do you do that? The little hotkey where you can change them all at the same time again?
Yeah, you highlight whatever you want. So you like double click or highlight it and do Command D, and it will select all of them, all of the same values, and then you can change them all.
Thank you.
Yep. So let's just check out the small array. CD into Python binary search. So the value of here, so this small array, what should this equal? Should it equal 1? It's the index. All right, that works there. Small array there. So 5 should equal 0, 1, 2, 3, 4. 4. We do the very large array. So 24, 29, 48. There we go. Questions about, and we can actually, let's run this and just kind of print some stuff out. But before we do that, we can actually get this a little more smaller. So we can actually, instead of assigning this to a brand new variable, we can totally get rid of that and just pass that into there. Same thing with the tracker index, the updated tracker index, we can get rid of that. Whoop. So we can actually just get rid of these two lines. So we can literally just return the target number in line, do the splicing here, and also add the tracker and middle index to the tracker index while we're passing it in. Same thing with the smaller array. We can do that and get rid of that as well. But we can keep track of print tracker index just to see it get larger each time. If we do this very large one, just 49, which the output should be 48. And we can see the tracker index get, every time it recursively calls, it can get bigger and bigger. So initially the tracker index is 0. So we cut that in half and we pass in the right side of the array. Therefore, the tracker index is 25, which is half of that. We cut that in half So half of 25 is around like 12 or 13, but it's 12. So we add that 12 on the 37. So now our tracker index is 37, and then keep going up until we find the actual value.
Tom, if I
Yep.
may,
Yep.
as we discussed yesterday, my only problem with this is that this actually becomes an n squared solution, because slicing the array in half introduces a loop in the middle of your loop. Right here on like line 44 and 41, doing that slicing is a loop. And so it would actually be faster in this case to just iterate across.
Is this a for loop? did
Yeah,
not
I
know
just
that.
tested it actually.
Oh,
I can show you the results. It's about 4 times faster or 4 times slower to do it that way.
Yeah, because it does a full rewrite to new memory every time.
I got you.
So I did this problem a couple days ago, and yesterday when we were talking about doing it recursively, I was so confused at why you would do it that way. So I actually did it just for the while loop. And I thought that was kind of like the default way of doing it, because I thought exactly what James was thinking.
Gotcha. Interesting. I did not know that. I never even tested that before. Cool. But yeah, I mean, the whole point of this is just to get used to recursion and like what binary search is. It's not so much specifically how you do that, but that is good to know if there is a more optimal way to do that. Do you want to push that solution and we can take a look at it if you haven't already?
Mine